Hello friends, welcome back. And as you guys know that I have recently started a new series called Creates in Rust. And to be honest, that series it didn't get that much attention and response. And to be honest, I wasn't expecting that. The reason for starting that series is because the grades are the major building blocks in the Rust ecosystem. That's why I have started it. And right now, I'm not sure that should I have to continue it or not. But for now, we will be continuing with the other videos, and we will explore other things. So if you guys following me for a while, then you might be remember that I have made one video called the digital clock in C language, and that video got so much love and attention. And in fact, that video has the most views among all my other videos on the channel. So I thought, why not to do the same thing in the Rust, this time in the Rust, but with the fancier look and the better alignment, just by using the Rust crates. So let's just start. I have created the project, and if you see right now, there are no dependencies. And what we need to do now, first we need to create our main function. And now for any clock, the what's the important thing which we need? Obviously the time. So for the time, we will be using the system time. And I'm sure you might be thinking, like, why not using the chrono? Because the chrono is the it's a simple thing to manipulate the date and time, to handle the date and time. For example, if I have the chrono added in my program, then I can easily say that by calling the local and the new, and then I can call the hour function, or I can call the minute function, and I can call the second function. And by doing that, I can get the hour, minute, and second easily. But the problem is, and it's my suggestion as well, and I will never recommend to add the complete grade just for handling this one thing. Just like in our case, we only need the hour, minute, and second, so it doesn't mean that we have to add the grade completely. We have to add the entire grade, because with this you will increase the binary size. And let's say you have already the terminal app and the cron is installed, and you have used manipulated dates and time in many places, and now you need to show the digital clock, or you need the hour, minute, and second. So for that reason, it will be perfectly fine to use that chrono. But just for handling, less like in our case, we need the hour, minute, and second, and nothing else. And we are not using it anywhere in our program, then I think we should have to avoid it to add the complete grade just to handle this thing. This will be, I will never recommend, and I will not say to use these kinds of approach, because with these little things you can make your binary smaller, and your app should be working really fast, as compared to just like if I add the grade completely, and just to handle the hour, minute, and second, I think it will be a stupid move. And what we are using now, we are using the system time. So for the system time, there is a now, and so we got the system time. And what we need, from where we need the duration. There is a duration since method from the Unix epoch, and we'll unwrap it. Okay, so now we have the number of seconds from the January 1st 1970, and we can easily get the hour, minutes, and second from that. So for calculating the hour, minute, and second for our digital clock, the first thing we need the total number of seconds, in a day. So for that, we can say that we have the now, and there's an as seconds method. We need to use a modulus, and how many seconds in a day? It's an 84,600 seconds in a day. So now we got the total seconds in a day. So for the hour part, we will calculate it from the total seconds, and we will do the what we need to do. We will use a 3600, and it will be the modulus of the not yeah it should be a 24. Okay, and for the minute part, what we need to do, we have the total seconds, and we will take the, and we will divide it by 60, and for the not the hour, for the second part, we will say that total seconds, and we will modulus is the 60. Okay, so by doing that, and also don't worry about these mathematical formulas or the calculations. You can easily search for it, and you will get all the formulas to calculate the hour, minute and second from the total number of seconds in a day. So this thing is not so don't get confused by these things. Okay, I know this is for the, if I use the chrono, it will be much easier, but I only need the hour, minute and second, so that's why I have I don't want to add the chrono grade to make my binary a little bit smaller, so that's why I'm not using it. And let's print this first. Okay, and for the print part, we will use the 2 digits number. And what we need to do now, we have the hour, we have the minute, and we have the second. So let's test this. Okay, so we got the I think we have missed the what do we have here? We have missed the column here. Let's run it again. Okay, so this time it's looking perfectly fine, and if I check the it's the perfect second and time. Okay. Okay. So now what? So we have short the timer, and as you can see, and the timer should be inside the loop. But first thing, I think we can easily so all of these things will be inside the loop, because we need the 1 second tick, and for that we need the continuous loop, and we will place everything inside this loop. Okay. Okay, so now I think let's test this, I think, one more time to check like how, and it will be 1 minute and second. Okay, so we got the time every second, the loop is working fine. And now what? As you can see, there is the continuous thing. So we need to clear the screen first, and then render the time. So for the clear screen part, we will create the function here, and this will be a clear screen, will not take any argument, and there will be no return time. And for the clear screen, we will be using the configuration macro, and we will be passing the compile time constant, which is the target OS, and target OS will be, let's say, Windows. For the Windows part, we will be using the command module from the, not the, it's a command struct from the process module, and we will be using the new, and what's this, the CMD, and then we need to pass the args. In the ASCII case, we will be passing, we need to execute it. For /c means we have to execute the command. Which command we need to execute? Which is the CLS command. And then we will check the status, and then we will come unwrap it. Okay, so for the else part, like for the Linux or the Mac OS or the Unix system, we will be using the clear command, and we will just simply get the status and unwrap it. So now we have the clear function, which we can easily call that in here before displaying the time. And let's test this again. Now see, you can easily this screen gets cleared, and there is some kind of a flicker. You will see on my screen the flicker. Let me explain why it's happening. This is the important part. Okay, this loop, this is in the continuous loop, and in 1 second there is a millions of the iterations happening, and you are seeing the second stick is working perfectly fine, but this is not the case right now. With this loop, the CPU usage is 100%, which we don't want and never wanted, because we have to pause this thread for 1 second to make it look like the exact digital clock, to make the second tick perfectly fine, and it should be aligned with the real digital clock. So that's why we will be using the thread module, and we will be using the sleep, and the duration we will be needing is the not the from, I think, yes, the from seconds will be 1. So if I run it again, you will see there will be no flicker at the, you see, the digital clock is working perfectly fine, just like the real one, and there is no flicker. So don't forget to add this line. Let me show you which line I'm talking about. At this one, okay, because if you forget about this line, you haven't added it, then your CPU usage will be 100%, which is not a good thing. So what now? We got the timer, and which is perfectly digital clock. So not a timer, digital clock is perfectly fine. What else we need here now? So we have completed our digital. Now we need to make it vertically center aligned and horizontally as well. So for that we need a crate called the terminal size, because we need the width and height of our terminal. So for that, let's add the crate called terminal size. Okay, it's get added. Let confirm. Okay, so dependency 0.4.3 union terminal size. And what do we need to do now? Okay, so we will. I think we don't. Okay. So for the terminal size, we will be using the terminal size, and this terminal size will return the option with the width and height tuple. So for that, if it's returning the option, then we can easily use the if let sum, and it will return the tuple. We will use the width by w, and the other thing will be height. We will say it's the h. So now we got the width and height of the terminal, and what else we need? Let me open the documentation of the terminal size crate. Okay, So okay, so for first we will center vertically. So for the center vertical, and we have the height. We need some kind of a loop. So we need, because we have to add the line break and move the cursor to the center. For that, we will say that for I in, and we will start from the 0. Now we need the center part, the center of the screen, but vertically. For that, we have the height, and we will divide it by 2. And for the safer side, if we need it in exact center, we can say that we will add the -1 for that as well, and we will add the print, not that. So by doing this, we will add the line breaks. And what else I think. Let's test it. Okay, so it's looking perfectly fine. It's centered aligned. Now it's vertically centered aligned. Now we need the horizontal alignment. For the horizontal part, what we need the width, but we need some kind of the padding from the left, because we have to move the cursor from the left to right. So we can say that left padding will be, and we have the width, and we will divide by 2. But there is a part of the digital clock which we need to minus from the complete width of the terminal. And for that, I think we can do that. But for the safer side, let's say the number gets it returns us the 0, not a 0 number. If it's returns the negative number, and we are not expecting any kind of a negative numbers, for the safer side, I will be using the saturated sub function. This function will return the, let's say if there is a negative number, it will return the 0. So there is no chance of returning the negative number. And for what length we need, for the length of the, I think we haven't stored anything related to. Okay, so we haven't stored it. Let's say it's the time str, and we will be use the format not format. We will be using the format macro, and what we can do now, and this will be in hour, minute, and second. So now we have the we need the length of the string. For the length of this string, we have the time str, and we will get the length, and we will divide it by 2. So we get the half of it. So we can easily show within the center. So from where the first digit will be start, with this approach we will have an idea. We are like using the two integers. One is the width and the other is the str length. Let me show you the type of this string. Is it's the U size, and what's the type of this? Oh, it's the unsigned 16. For the, if you are working on the Rust, you knew that if you are working with the two integer types, and the type should be same. So for that, we can pass it with the, we can pass it to the U size. So now we got the left padding. What can we do now? we need some kind of a space here, and for the space part I think we can use the print first, and we will be using the approach for that width, and it will be replaced with the empty spaces, and width variable will be filled with the left padding, so that placeholder will be filled with the left padding width. Now we will use the print macro again, but this time we will be showing the time str, and we will remove that. Now let's test it again. It's not, it's I think it's horizontally aligned but not vertically. Let's debug this. Let's debug it, and first thing we need the underscore, and I will comment that center horizontally. We'll save it, and maybe there is some kind of a mistake here. We got the height. Let me confirm by terminal size create that if it's it's not. I think it's not printing immediately because we have used the print. Okay, so there is a one thing. So if you are using the print macro, I have mentioned this in my previous videos as well, that you have to flash this because it's written to the buffer memory, and for the buffer memory we need to flash it, so the text get printed to the console. For that we will be using the standard output, and we will just simply flash it. Okay, now I think I'm sure it will be okay. So we got, oh sorry, instead of doing that we will unwrap it. Okay, so it's working perfectly fine. Now it's horizontally and vertically center aligned. It's looking pretty good. And now let's, I think, change the color of the text. So for changing the color, or you want to say that if you want to change the foreground, background of the color of the text, for that there is a crate called crossterm. Let me add the crossterm first. Okay, so what can we do now? We have the crossterm. So let me add the more placeholder here, and we will say the first we need to say there is a struct called set foreground, and we will be passing the color enum, and we will be using the green, and we need to pass the time str, and we will reset the color as well. Okay, I think it's looking fine, and let's test this one more time. Okay, so we got the color change. Now color is green. You can use any color you want, and it's looking perfectly fine. Let's make it Okay. First, I think we need to add the, if there is a set attribute, and attribute will be enum, and let's say we want to make it bold, and we need to pass the time str, and we will reset color as well. Where we got the error? These are 4 placeholders which I have added. Maybe there is another way. Come on, that's the foreground color. Okay. Maybe it's not the case for the print macro. It will not accept, or what happened here? Set attribute. If I move this, it will work. It will be working fine. I don't know why it's happening, but for now we will stick with these the 3 params, and the clock is looking perfectly fine. So now what? Actually, the font size is much smaller. If you we need to make it bigger. So for the bigger font size, if you want to handle, you want to increase the font size, you there's a way by using the grid called the figlet, and the figlet converts the string to the ASCII art, and by doing that, there will be a different symbols combination. The text size will get increased, and what we need to do now, we can we will add the not N1, we will add the what's called the figlet-rs. I think it's a figlet-rs, yeah. It's the actual cursor, and it's the figlet-rs. Figlet-rs. Let me add this. So now, if we want to increase the font size, there is a one catch in it. Not one catch. There is something like in terms of the height and width, like horizontally or the vertically alignment. We need to change this code, because for the ASCII art, there will be multiple lines used, because the height and the width of that string will gets increased. So now we need to calculate it again, like to where we need to show the text, and what changes we need. So the first thing we need is we need to let me was, and also okay, and where is it? And I think okay, so let's check that. Okay, the figlet rs edit, So the first thing we need to load the standard font. For that, but we will be using the variable called standard font, and this will be font and will be standard, and we will unwrap it. Okay, so now the standard fonts get added, and now we have the time str. We need to convert this time str to a figure. For that, we will be using the standard font convert method, and we will be passing the time str by reference, and we need to unwrap this as well. Okay. So let me run the app again to make sure everything is working fine. Yeah, it's working fine. Okay, so we got the figure now. So there we need to change the, so now we need to measure the height again, because it will convert it to the ASCII art. In the sign there should be a multiple symbols, and the height should be increased. There are multiple lines involved, so we need to get those lines. So first thing, we need to change it to the, what do we need, a figure, I think figure str will be a fine name for this, and we need to change it to string. And now what do we need to do now? Let me open the documentation. We have already need to know in the terminal size. We need the, okay, so what we got here? So we got the figure str. We have converted to string because we need the number of lines, so that the that ASCII art will definitely have the new line breaks. And to get those new line breaks, we need the lines variable, and for that str we will get the lines. Here is the line function, and what we need to do now, and we need to collect it. So we need the vector for that, to count how many lines we have. So that, I think we can do it that it should be an str type. Okay, so now we have we knew how many lines we have. Okay, let's print it what these lines have, just to test these lines. Okay, so we got these lines, combination in our collect vector form, and let's test this by doing, I think we can do that for line in lines, and we can have to make it print on every new line just to call the line. Now test it again. Okay, so it's looking like that. It renders everything, and our timer is the convert to the ASCII art. Okay, so looking fine. What we need to do now, we got the height and we got the line numbers, and we don't need it here. Okay. So for the center vertically, we need the vertical padding. For that, we will define the variable called vertical padding, and we can get that from, we have the height. We will subtract the lines from that height, because the ASCII art there will be multiple lines involved, so we need to get the lines length, divide it completely by 2. Complete height divided by 2. And what's this length? Obviously, this will be a U size, and height will be unsigned 16. So this time we will be convert this to unsigned 16. I think it will be fine. Let me check it. And yeah, unsigned 16 is fine. So we will save. Now we got the vertical padding. We need to update our loop. So now from 0 to vertical padding. Let's test this again. Okay, so it's looking fine. Not in complete center. I don't know why. Because okay, so obviously we haven't used the figure. So I think we can use a figure str. Where is it? Maybe we can say that. Okay, it's fine. It's converted to figure str. There are some issues left. I think it's this. Why it's doing like that? Because we haven't calculated the padding according to this new figure. So let me remove this code. And what we need to do now, we need for that, for the width part, we need the spaces from the beginning, but there will be, I think we can do that in the lines. And the first thing which we need to calculate is the obviously the left padding. So for the left padding part, I think we can do the same thing. So it will be left padding will be, we have the width and we will divide it by 2, and we will subtract. Now what we need to subtract, we need to subtract the line dot length now this time, and this will be 2, and of course we need to pass this to U size as well. So we got the left padding, so we need to print, use the print macro. We will say that replace it with the empty string, and width will be left padding. Okay, so all the spaces will get added here. Now we need to show the there will be a 3 params, and the first one will be set a foreground color, and color will be green, and I think this time we can use the blue color. It will be looking, I think, much better. And what will be the time str? Not time str, it will be a figure str. I think it will be a figure str. And not a figure str, we are in the loop, so we need the line. We need to print the line every time, every symbol we have to print it. So by doing that we can create our and what we need to do, we need to reset the color as well. So I think it will go fine. We have flushed the, yeah, we have flushed the, so let's that not that okay, let's test it again. What's happening here? Why the cursor is moving? I think missing, which is the okay. So there's for every time the symbols gets present, we need to add the line break as well. Maybe this will resolve the issue. Yeah, it's perfectly looking fine now. I think blue is a much better color. So the seconds are taking perfectly fine. Okay, so the fancy fonts and the indentation is not the indentation, the alignment is looking very good. Okay, now what else we need to do? Let me check the code again. Maybe is there anything which we can improve? So we have used the cross template. So instead of clearing the screen by using the configuration macro, I think we can use the let me show you a better way, because we are using the cross term for many other reasons, like to changing the colors and for the reset color. So that's why I think we can use the clear struct of the cross term as well, instead of writing the platform specific code. And let me show you an example. Let me remove this code, we don't need it. And let me show you the better approach. Let's remove this and first there is an execute macro which takes the standard output, and the other thing is a clear struct, and there will be a clear type, and there is an all. So let's try it again. Okay. We will, I think, unwrap it. Okay, so it's looking fine. Let me run it again. Why the X move to the end? You will feel like the cursor is moving to the new line every time. Okay, I think it's not we need to readjust the cursor, I think, because let me adjust this by doing there is a function, no, not a function, there is a struct called move to, and we will be passing the 0 0. So every time the screen gets cleared, the cursor will move to the top left, and so it will be the move to the 0 0 0 column 0 row, and we will reposition our cursor. Hope this work. Okay, so yeah, this was the issue, and let me explain it why this was happening. So if you are using the configuration macro, that configuration macro already handle the like the it make after clearing the screen, it makes move the cursor to the 0 position, and but if you use the execute macro, you have to do it by yourself, and you have to move your cursor to the you have to reposition your cursor. So that's why we are getting that issue. We got that issue, and now let's check what else we need. Also, You might be thinking that why I have you remove the clear screen function, because if you are using the cross term, and the cross term is the like the uh, it's tested on the Linux, Mac, and Windows, so you don't have to worry about all the issues with the by using the multiple browsers on the different OS. And the crossterm will handle all these issues for you, so you don't have to worry about it, and you don't have to write the platform specific code. And if you are writing the platform specific code by using the configuration, it means that you have to handle other issues as well. Let's say if it will maybe it will not work on the other OS. So it's a cross term is the cross platform. Great. And also if you check, and wait a second, let me, we have used the standard output in two places. We can make refactor our code and make it better as well, because instead of creating new handle every time, I think we can do that. We will be using the standard out here, and we'll define it into, assign it to a variable. And I have defined a mutable variable because the internal buffer changes, so it updates. So that's why I have defined the mutable standard output. And now what we need to do, we can remove this parenthesis, and from where we need to do, yeah, from this section we need to change it, and yeah, remove the unused import as well. And let's test it again. Okay, it's looking good and looking perfectly fine. Okay. And one more thing, there is a formatting issue. There are so many imports. Let me move to the source directory and use the resfmt main. And by doing that, yeah, so the imports get formatted. It's looking fine now and much better. And let me check all the code. Maybe there is something else we need to refactor it or make it better. I think everything is fine now, and I hope you guys enjoyed this video, and I'm sure you guys will learn new things, because there are so many things which we handled in this video. And the most important thing, if you notice that I haven't explained a single grade, like we have used the, if I check this, there are three grades used, the cross term, the figlet, and the terminal size. I haven't explained not a single one. The reason for this is because in the series of the grades and Rust, there are dedicated videos which I have made explaining everything about these three grades. I will also attach the link of all those three videos in the description, and also the code link in the description as well. So you guys can run on your machine, and you can update the code, change the color, and learn from it. And so watch those videos for the grade. If you have issues, like if you are not getting that how the terminal size, the figlet, or the cross term is working, all these so I have made the dedicated videos, and those dedicated videos have the examples as well, so you will have a better idea. So my recommendation is, you have to watch first those three videos, and then try this digital clock. Things will be much clearer for you. So I hope you guys enjoyed it, and see you in the next one. Take care. Bye.